Realization of basic gates using universal gates. Now, there are 7 basic gates: NOT, AND, NAND, OR, NOR, XOR, and XNOR. Out of these, NAND and NOR are two universal gates. We will be focusing on NAND in this video, and this is most likely what is to come in your exams. But just for safety measure, I will also be uploading a video on using NOR. Now, using NAND, we are going to make NOT, AND, OR, NOR, XOR, and XNOR. Now, it might seem like a lot, but most of these are really simple and just one step ahead of the next one. Let's start with the easiest of all, NOT gate. Now, to create a NOT gate using NAND gate, let's first have the truth table of NOT gate up over here. As you can see, a NOT gate only has one input line, and when it's 0, the output is 1, and when it's 1, the output is 0. However, a NAND IC or a NAND gate has two input lines. Well, let's put up the truth table of a NAND gate. As we can see, when both the inputs are 0 in a NAND gate, the output is 1. And when both the inputs are 1 in the NAND gate, the output is 0. So, there is a way we can trick the IC into thinking only one input is being used. Firstly, let's add the NAND IC into this middle IC base over here. I'm going to click on Add IC, click on that IC, find my NAND IC number, click on that, add it, and then connect the ground, and then connect the voltage. Now, having done so, as we saw in the truth table, when both the inputs in a NAND gate were 0, output was 1, and when both the inputs in the NAND gate was 1, output was 0. I'm going to put up the X-ray of this IC just for your betterment of understanding. And now what I can do is take one input line, connect it to the first input of the first NAND gate, then take the same input line, connect it to the second input line of the first AND gate, and then take its output and put it in the output bulb. Now if we power it on, when this is 0, that is 1, and when this is 1, that is 0. This is how you create a NOT gate using NAND. Now, to create AND using a NAND gate. Well, as we know, NAND gate means not AND, which is opposite of AND. So suppose if you were looking forwards and somebody rotated you 180 degrees, then you'd be looking backwards. Then looking forwards is AND and looking backwards is NAND. But what if somebody rotated you 180 degrees again? You'll be looking forwards. So what if we take the NAND operation and then we pass it through a NOT gate? Then doesn't that become an AND gate? And remember, there are no inertial NOT gates here. So you'll need to use a NAND IC to create that. To do so, first we have the IC. I'm going to add my NAND IC. Then as per the diagram, we take our first signal and put it into the first line. We take our second signal, we put it into the second line. We take the output of it and then put it in the first line of second NAND gate. And then that same output will be put onto the second line of that second NAND gate. Having done so, we get our output and connect it to a bulb. Then we connect our voltage and ground. And if we power it on, Voila, we have our AND gate. Now to create an OR gate using NAND gates, let's look at that diagram here. This looks like a NOT gate you created using NAND. This too looks like a NOT gate created using NAND. This one houses one input and this one houses the other input. Now the outputs of these come together into the third NAND gate, which give us the output of our OR signal. Okay, let's try that. Let's add our IC, and as per the diagram, let's first create our first NOT gate. So we take our signal, we put it over there, we take our signal again, we put it over there. Then as per the diagram, second NAND gate uses the second signal. So we take our second signal, we put it over this input line. We take that same signal and we put it over to its second input line. And now the third NAND gate uses the output of the first NAND gate and the second NAND gate. So let's take the output of our first NAND gate and put it over to this input line. And let's take the output of our second NAND gate and put it over to this input line. Now the output of this becomes our OR operation. Let's quickly connect the voltage and the ground. Having done so, if you power it on, then voila, we have our OR gate. Now to create a NOR gate using NAND gates, we need to use 4 NAND ICs. But if you look closely, we can see that this configuration right here is what we just made, which is an OR gate. And supposedly that's being passed through a NOT gate made out of NAND, which makes sense because NOR means not OR, basically the opposite of OR. And the way to make something opposite is pass it through a NOT gate. And we know how to create a NOT gate using NAND. So what we can do is we remove our output line, and this is where our OR operations output is coming from. So all we need to do is invert it through a NOT operation. To do that, we take it into the first signal of another NAND gate IC, put it to its second signal again, and the output is our bulb. We power it on, we have our NOR gate. Now to create a XOR or exclusive OR using NAND. Basically, the signal should only be sent when only one input line is active. Let's look at this diagram. If we see this diagram, we see two input lines as usual. First operation of a NAND gate is B is coming into this and A is coming into this. Fairly simple. Now if we look at the second gate, we see that the output of the first operation is again being operated with the first signal, which is A. Then if we look at the third gate, we see that the output of the first operation again is being operated with the second signal, which is B. And the output of these two operations are being done into another NAND gate, which becomes our XOR. Let's start doing that. Following the diagram, we add our IC. And just to avoid confusion, I'm going to connect my VCC and ground first this time. I take my first input. I put it in the first line of the first NAND gate. Second input goes in the second line. And we have our first operation completed. To do the second operation, I take the output of the first operation into another input line. I take my first input into the other input line, and we have our second operation completed. To do the third operation, we take the output of the first input line again. Then we take the second input line again. We paste it. we have our third operation completed also. Now finally we take the remaining output lines, put them into the remaining input lines, and take the output, and it becomes a XOR. Now to create an XNOR gate using NAND gates, we can fairly try to assume one thing by its own name. XOR means exclusive OR, and XNOR means exclusive not OR. So if you've guessed correctly, basically as per the diagram, all we need to do is put our XOR's output into a NOT gate. However, if we notice correctly, we've used up all of our IC gates in this IC. Now we need to add a second IC. I click on add IC, I click on this, I click on my NAND gate IC, then I remove my output line connection, and instead I take it and put it over to this first input line, and I take it again and put it over to this second input line, and the output of this becomes my exclusive not OR. Basically all we are doing here is performing a NOT operation. I connect my ground to ground, I connect my voltage to voltage, and if I turn it on, both my inputs are off, there's a signal. I turn either one on, there's no signal. I turn both on, voila, there's a signal. We've covered all the basic gates using NAND. Best of luck all.